is to delegate to a helper method, but that's cumbersome because you still need to write the 3 overloads and implement them, delegate them to a helper method. With explicit object parameters, you can avoid this, and you can just, instead of having 3 overloads, you can have only 1. And in this context, this feature is called deducing this. So instead of my 3 getName overloads, I write 1 member function template. The return value becomes autorefref, and like before, the first parameter to my function is this self-refref self, and then in the body of this member function, you don't use this, as there is no this pointer. You use this explicit object parameter. What else can you do with it? You can use this feature to write recursive lambda expressions. Normally, if you have a lambda expression and you use this inside the lambda expression, you will access the object that contains your lambda expression. You are not accessing the lambda function object that generated. So you cannot have a recursive lambda expression. With explicit object parameters, you can. So here I have a Fibonacci lambda expression, and I'm using an explicit object parameter, this auto self. And once I have this inside the body of my lambda expression, I can call self. So I can call the lambda expression can recursively call itself. Next one, if const eval. What is the syntax? It's straightforward. You just write if const eval A, else B. As you can see, there is no condition. It's just if const eval. The braces are mandatory. With a normal if statement, the braces for if there is a single statement, you don't need them. In this case, they are mandatory. And what's the effect of this? The effect is that if this statement is executed at compile time or in a constant evaluation, then A is executed, otherwise B. So why do we have this? Because we already have a function in the standard library called isConstantEvaluated. So what is wrong if you write if isConstantEvaluated A, otherwise B? Not much. It's actually equivalent, almost equivalent. If const eval is part of the core language, you don't need to include any header files or any modules. Within an if const eval block, you can call other const eval functions, which is not possible if you use the isConstantEvaluated. And maybe more importantly is that if const eval cannot be used wrong, while if isConstantEvaluated can. Because I've seen that some people think that isConstantEvaluated need to be written like at the bottom line, so if const expr is constantEvaluated. But obviously, if const expr will execute at compile time, and at compile time, isConstantEvaluated would always be true. So that last statement is the same as just writing A. B will never be executed. So here is an example. I have a const eval function f, also called an immediate function. I have a const expr function g, and in this const expr function, I can check if I'm being called at compile time or not. So one thing, const eval functions, they are guaranteed to be executed at compile time, while const expr functions can be evaluated at compile time or at runtime. So if you want to execute a const eval function from inside a const expr function, you need to make sure that you are in a constant evaluation context, and you can do that with if const eval. So here in the if const eval, I'm calling my f immediate function. In the else statement, for example, in the else block, I would not be allowed to call f. And I have a third function, h, which is also an immediate function. Yeah, and this one obviously can always unconditionally call other immediate functions. This is also a nice one, multi-dimensional subscript operator. In the past, if you had multi-dimensional data, you had two options. You can either use the function call syntax to access an element of your data, or you can use multi-level indexing. Now in C++23, you can have proper multi-dimensional subscript operators. And implementing them is straightforward. You just implement your operator square bracket as you're used to, except instead of accepting one index, You accept as many indices as you need, and in this case,